What is a nucleotide?
A biochemical molecule consisting of a nucleobase, a sugar molecule, and one phosphate group.
What is the freezing point?
Temperature at which liquid and solid phases coexist in equilibrium.
Does eating chocolate or fried food cause acne?
No. Acne is caused by oil glands in a person's skin overproducing an oil called sebum, which is what the body naturally uses to keep skin lubricated. If this excess oil, along with dead skin cells, blocks your pores, then your skin can become irritated and a pimple may form. While the causes of excess sebum production are not definitively established, there is no reason to think that chocolate or fried foods are at fault.
What is a chiral center?
An atom whose arrangement of substituents is non-superimposable with its mirror image.
What is an ideal solution?
An ideal solution describes a solution of dilute solute particles that do not interact with one another. It is very similar to an ideal gas, except that instead of empty space occupying the space between the gas particles, a weakly interacting solvent occupies the space between solute particles.
How is ethanol produced for use as a fuel?
Ethanol is produced by fermenting sugars from plants like corn, soybeans, and sugarcane. The sugars in the plant material are first broken down and then fed to yeast, which ferments them to produce ethanol as a byproduct.
Why did Jacobus Henricus van 't Hoff win the Nobel Prize for Chemistry?
For discovery of the laws of chemical dynamics and osmotic pressure in solutions. The first Nobel Prize ever awarded went to van 't Hoff for his discoveries surrounding osmotic pressure and chemical equilibrium. If a solution of sugar water was separated from a volume of pure water by a membrane that allowed water, but not sugar, to pass, van 't Hoff discovered that additional water would force its way across the membrane until an equilibrium was established. This results in a greater pressure on the side to which the water is moving, and this pressure is known as osmotic pressure.
What fraction of atoms are empty space?
The fraction of an atom that is occupied by empty space is very large. In fact, over 99.9% of atoms are empty space. The protons, neutrons, and electrons are incredibly small. And the atom occupies such a relatively large effective volume because of the delocalized electron cloud around the nucleus.
What's the difference between brown and white eggs?
Besides their color, the only difference is the color of the chicken that laid it. White-feathered chickens lay white eggs, brown-feathered chickens lay brown eggs. That's it. The inside of the eggs are identical in every way, assuming the chickens you're comparing were on identical diets.
Why did Richard Adolf Zsigmondy, Germany/Hungary, win the Nobel Prize for Chemistry?
For his demonstration of the heterogeneous nature of colloid solutions and for the methods he used. Although the Nobel Committee didn't mention it by name. The methods he used refers to Zsigmondy's invention of the ultramicroscope, which allowed a visible light microscope to see objects that are smaller than the wavelength of light. Zsigmondy accomplished this, literally, physically impossible task by looking at the light that scattered off of a sample, and not the light that it reflects. Using this new tool, he showed that the red color in so-called cranberry glass was due to small 4 nanometers, particles of gold, which was of interest to his employer at the time, shot glass.
What is kinetic energy?
Kinetic energy is the type of energy associated with the movement of an object. Faster moving objects have more kinetic energy, and the kinetic energy of an object is related to its mass, m, and velocity, v, by the equation, E equals 1/2 mv2. This tells us that, for example, if we have two objects of equal mass and one is moving twice as fast as the other, the faster moving object will have 4 times the energy of the slower object. In this illustration, a horse pulls a pendulum into a position where it is about to be released to swing freely. Before it is released, the weight at the end of the pendulum has potential energy A, and when the pendulum is in full swing, it has kinetic energy B.
What is fluorescence?
Fluorescence is a process by which molecules that have absorbed light can re-emit light to release some of the energy they absorbed. For fluorescence to take place, a molecule must first absorb a photon of light. which causes an electron to be excited to a higher energy level. At the same time, this process will typically also cause some vibrational excitations to take place. Some of the energy associated with this absorption will be given off through relaxation of the excited vibrational energy levels. For fluorescence to occur, the electronic excitation relaxes by emitting a photon of light. Some of the energy was dissipated as the vibrational energy levels relaxed. So the photon that is emitted has less energy than the photon that was initially absorbed. Remember that less energy means a lower frequency. So the photons that are emitted have a lower frequency than those that were absorbed.
Why did Linus Carl Pauling, United States, win the Nobel Prize for Chemistry?
For his research into the nature of the chemical bond and its application to the elucidation of the structure of complex substances. Pauling made significant progress toward understanding the nature of chemical bonds, which are, obviously, relevant to virtually all chemical processes. He proposed the property of electronegativity as a means for characterizing chemical bonds. And he developed a scale for electronegativity values. Pauling's work with X-rays also uncovered the structures of numerous molecules and paved the road for X-ray diffraction as a characterization method for even more complex molecules. In 1963, Pauling also was awarded a Nobel Peace Prize. Throughout his career, Pauling was always known for working and living at the forefront of scientific discovery.
How do you measure the pH of a solution?
One of the first ways science students usually learn to test the pH of a solution is by using pH paper. This is a pretty simple test that only requires you to place a drop of the solution onto the paper and to look at its color. The color change accompanying changes in pH is due to a chemical indicator whose absorption spectrum changes with changes in pH. Another way to measure pH is with a pH-sensitive electrode. This can provide a more accurate measure of pH, as it digitally outputs the pH as a number value and does not rely on a person visually inspecting a color change to interpret the result.
How can I suck an egg into a bottle?
Chemistry principles encountered in this experiment: combustion pressure, ideal gas laws, materials you'll need. Hard-boiled egg bottle or flask with an opening slightly smaller than the egg's diameter, paper. A sheet of computer paper or newspaper will do, matches the procedure. Note, this experiment involves fire and flammable materials, so adult supervision is a must. Peel the hard-boiled egg. Tear off a piece of paper that can easily fit into the bottle. and carefully light it on fire and drop it into the bottle. Quickly place the egg on top of the bottle, covering the opening. The flame will burn, heating the air inside the bottle. This causes the air to expand, and some of it will push past the egg to escape from the bottle. Recall from our discussion of the ideal gas law that, for a fixed number of particles and volume, the pressure inside the bottle should increase linearly with increases in temperature. The increased pressure is what pushes the air out. And you may even see the egg shake a little as the air escapes. Then the egg will come to rest, covering the opening. Eventually, the fire will burn up all of the paper, or all of the oxygen inside the bottle. Whichever comes first, and then the air in the bottle will begin to cool. As it cools, the volume it occupies will decrease, lowering the pressure inside the bottle relative to that outside the bottle. The higher pressure outside the bottle is what pushes the egg through the opening and into the bottle. You can get the egg back out by tilting the bottle upside down and blowing air into the bottle, and then allowing the egg to cover the opening before removing your mouth. Thus you can use the same principle regarding equilibration between high and low pressures to force the egg out.
What is Splenda, R?
Splenda, R, is a commercial name for an artificial sweetener, like NutraSweet, R, or Equal, R. Sucralose is the key sweet ingredient in Splenda, R, but unlike natural sugar molecules, sucralose is not metabolized, so it effectively has 0 calories. It's made from regular table sugar by selectively exchanging 3 O groups for chlorine atoms.
What was the Bhopal disaster?
The Bhopal disaster, also referred to as the Bhopal gas tragedy, was a gas leak in Bhopal, India, that happened in December of 1984. At the Union Carbide plant in Bhopal, methyl isocyanate gas was accidentally released during a manufacturing process. The gas poisoned thousands of people in the surrounding city, most of whom were asleep when the gas leak occurred. The effects of the release of this gas were felt for years to come, with over 500,000 injuries reported in the nearly 3 decades since the incident. Following this accident, criminal and civil suits were filed against the company and several of its highest-ranking employees.
What is kinetics?
The rate of chemical reactions or processes.
What will happen to the gum I just accidentally swallowed?
When you were a kid, your parents or teachers probably told you, or at least they told us, not to swallow your chewing gum because it would take years to digest. Actually, your body can do just fine with digesting the flavor components, sugars and sweeteners, and softening ingredients in chewing gum. It's only the gum base that you cannot digest. However, just because you cannot digest it does not mean it will stay around in your body for several years. The gum base will just typically pass through your digestive system in just a few days' time. But please don't try to swallow a bunch of gum at the same time, though it can get stuck and cause all sorts of problems.
Why might a soft drink freeze when you open it?
Remember that the freezing point of a solution is decreased by having anything dissolved in it. When a soft drink is opened and CO2 rushes out, less CO2 is present in the solution, causing the freezing point of the solution to increase. So at a constant temperature, the increase in freezing point causes the soda to freeze. If you haven't seen this happen, you can try to make it happen by placing a soda in the freezer for a while. But be careful not to leave it in too long or it might explode.
What does infrared, IR, spectroscopy measure, and what does it tell you about a compound?
Infrared spectroscopy measures the absorption of light by molecules in the infrared region of the spectrum, which provides information on the types of functional groups present in a molecule. For example, looking at the infrared spectrum can provide evidence as to whether certain pairs of atoms are bonded by 1, 2, or 3 pairs of electrons. The shapes of the peaks in an infrared spectrum can also be used to gain information about intermolecular interactions between the species we are looking at and the surrounding medium.
What happens chemically that causes a hangover?
Hangovers are believed to be caused by the buildup of acetaldehyde. This aldehyde is formed from the oxidation of ethanol, which is of course the alcohol you drank in the first place. Acetaldehyde is an intermediate in your body's process for dealing with all that booze you drank last night. An enzyme, acetaldehyde dehydrogenase, further oxidizes acetaldehyde to acetic acid. Of course, there are a lot of other factors that might make you feel terrible the morning after a big night out. Your liver gets pretty taxed dealing with all of the toxins, which is why some people think that distilled alcohol, which removes heavier molecules in the alcoholic beverage, leads to less severe hangovers.
What is a monodentate?
a ligand that coordinates to a central atom via only one atom, compare with chelate.
What is the Raoult's law?
States that the vapor pressure of a solution depends on the amount, mole fraction, of a solute added to it.
Why did Jaroslav Hayrovsky, Czechoslovakia, win the Nobel Prize for Chemistry?
For his discovery and development of the polarographic methods of analysis. Hayrovsky was an innovator in the field of chemical analysis. Developing a polarographic method of analysis capable of analyzing the presence of virtually any species dissolved in water, and could determine the relative percentages of the species present. He did this using a method that we won't get into here, but it relied on a fairly simple procedure involving the application of a current and measuring drops of mercury.
How do we write an equation for a chemical reaction?
Chemists often write equations to describe chemical reactions. It is conventional to list the initial species, or reactants, on the left side of the equation, followed by an arrow, and the final species, or products, on the right side of the equation. The equation below shows the reaction of methane and oxygen to produce water and carbon dioxide. CH4 plus 2O2 asterisk CO2 plus 2H2O. The arrow to the right indicates that the reactant species are converted to the product species during the course of the reaction. In some cases, reactions are reversible, which will be represented by two arrows, one pointing in either direction, D. Be careful, because in chemistry asterisk is not the same as D.
Why does bleach kill everything?
The active ingredient in bleach, sodium hypochlorite, NaOCl, has a few ways of killing off microbes. One method involves causing particular proteins in the microbes to unfold, preventing their normal function and eventually killing the bacteria. Alternatively, bleach can disrupt the membrane that forms the outer shell of a bacteria. Since most bacterial membranes are very similar, bleach is very effective against a whole host of different types of bacteria. The human body actually produces hypochlorous acid, HOCl, itself to combat bacterial infections.
What is permafrost?
Permafrost is soil that is below the freezing point of water for 2 consecutive years or more. Most of it is located near the North or South poles or at very high altitudes.
Is a calorie in food the same as the unit of energy used by scientists?
The calories listed on food labels are actually kilocalories when converted to standard units for energy. So if the package for your snack says it contains 100 calories, that's really 100,000 calories in the units of energy used by scientists.
What is qualitative analysis?
Analysis of the identity of the constituent species present in a sample.
How does one determine the oxidation state of an organometallic complex?
There are a few ways to approach this problem, and, of course, every chemist thinks the way they use is the most correct. But let's look at what is hopefully the simplest way to think about this. We're going to only talk about complexes with metal-carbon bonds and no other types of ligands. If you're curious enough to want to know how nitroxide binds a transition metal, chances are you have an inorganic chemistry textbook at home anyway. Okay, let's look at tetra, methyl, zirconium, which has no net charge. In this counting technique, all of the electrons in the metal-carbon bonds are placed on the carbon atoms. So we get 4 methyl anions and 1 zirconium ion. Since this complex has no net charge, the zirconium center must balance out the net 4 negative charges from the methyl groups. Zirconium must be in the +4 oxidation state. Easy, right? One more example, K3Fe, Cn, 6 or potassium hexacyanoferrate. We again move the electrons in the metal-carbon bonds to the carbon groups, making 6 cyanide ions, Cn, an iron ion, and 3 potassium ions. We have 6 negative charges, 6 Cn, and 3 positive charges, 3 K and ions. So to balance out the charges, the iron center must be in the +3 oxidation state. Zrme4 for Me1 plus Zr4 plus K3 Fe, Cn, 6 3K1 plus 6 Cn1 plus Fe3 plus. It's important to remember that when we count electrons in this way, we're doing only that counting. Don't get the idea that all of these metal-carbon bonds are the same, or that they're all ionic bonds. This is just for electron bookkeeping.
How many different chemical substances have been discovered?
According to the Chemical Abstracts Service, CA, which is the world's largest authority for chemical information, the 70 millionth chemical compound was recently registered, announced December 2012. Today, new chemicals are being discovered and registered at a staggering rate. The 60 millionth chemical was registered only 18 months earlier.
What is magnetic permeability?
The magnetic permeability of a material describes the extent to which it is able to support a magnetic field inside itself. It describes the amount of magnetization that takes place in a material when an external magnetic field is applied. Materials with a high magnetic permeability are able to support a stronger magnetic field within themselves.
What is a peptide bond?
A peptide bond, or peptide linkage, is the bond that links the individual amino acids in a peptide. Have a look at the figure of the dipeptide below. The formation of a peptide linkage is carried out by a structure called the ribosome, which is responsible for generating peptides and/or proteins based on the sequence of nucleotides present in an RNA molecule. We'll get to the details of this process a little later.
What is the elementary reaction?
Single step in a chemical reaction.
What happens in the frontal lobe?
The frontal lobe is responsible for decision-making processes and problem-solving as well as managing your active memory.
What determines the most favorable packing arrangement?
Thermodynamics. Okay, that's a cop-out answer. Attractive interactions, like van der Waals forces or hydrogen bonding, can play a large role in determining the stability of a crystal lattice. The most stable packing arrangement can also depend on the pressure and temperature at which the crystal forms.
What are the different parts of the brain?
The brain is divided into several areas that specialize in different functions. Some of the major sections of the brain are the frontal lobe, the parietal lobe, the temporal lobe, the pons, the medulla oblongata, the occipital lobe, and the cerebellum. The spinal cord connects the brain to the body via millions of nerves that transmit information between the brain and the rest of the body.
Why do hard-boiled egg yolks turn green?
When egg whites cook, a small amount of hydrogen sulfide, H2S, is released from sulfur-containing amino acids like cysteine or methionine. If the H2S migrates to the yolk, it combines with iron atoms to produce ferrous sulfide. FeS, which is a dark-colored material that looks green mixed with the bright yellow yolk. Ferric sulfide, Fe2S3, is also sometimes claimed to be formed in this process. Likely because it is itself a yellow-green substance. There is, however, less data to back this up, aside from the convenient color match.
What is an atomic radius?
Half the distance between nuclei of the same element.
What is pyrophoric?
A substance that tends to ignite readily and spontaneously upon exposure to air.
What is the Presidential Green Chemistry Challenge Award?
These awards were created in 1995 in an effort to promote and recognize innovation in green chemistry in the United States. 5 awards are given each year to individuals or companies for work in green chemistry in the following categories: academic, small business, greener synthetic pathways, green reaction conditions, and designing greener chemicals. Away from individual companies and placed it on the government agency. These laws received criticism for not incentivizing research and education regarding green chemistry in the industry. Due to widespread opposition to the initially proposed regulations, the implementation of this initiative had to be postponed at least once due to the need to rewrite the proposal.
What are some of the first organometallic complexes, and when were they discovered?
Among the earliest organometallic complexes was a compound known as cacodyl, or tetramethyldiarsine. This compound, with the chemical formula C4H12S2, shown below at left, was first discovered in 1760 and was known for its toxicity and terrible odor. The first platinum olefin complex, C2H4Cl3KPT, also known as Zeiss salt, see below, right, was discovered in 1829. This early organometallic complex was influential in establishing some of the essential underlying concepts that have since become crucial to organometallic chemistry.
What is entropy?
Entropy is a measure of the total number of microstates in a system. There have been 2 widely used definitions of entropy, which were suggested by Ludwig Boltzmann and J. Willard Gibbs. We'll just look at the one specified by Boltzmann, since it's a little more straightforward to understand. The equation for Boltzmann's definition of entropy is S equals kBln, in this equation. Kb is Boltzmann's constant, and is the number of microstates accessible to a system. To get an idea of how entropy works, consider the example of rolling one or more six-sided die. On the first roll, there are 6 possible outcomes. So the entropy associated with rolling one die is kBln, 6. If we roll 2 dice, there are 62 equals 36 possible outcomes, and the associated entropy is kBln, 36. For 3, it's 63 equals 216 possible outcomes, and the associated entropy is kBln, 216. As you can see, the number of outcomes for statistically independent events grows very rapidly. Exponentially, with the size of our system, which is also true for molecules. By taking the logarithm of the number of outcomes, we make the entropy scale linearly with system size. While the number of possible outcomes/configurations grows exponentially with system size. The entropy grows linearly, which means that if we double the system size, we double the entropy. This property makes entropy fall into a category of variables known as extensive variables, which just means that they scale with the size of a system in this simple way.
What's the difference between an H-bomb and an A-bomb?
The hydrogen bomb, H-bomb, is actually significantly more destructive than even an A-bomb. While A-bombs release energy via chain fission reactions, breaking apart heavy nuclei. H-bombs release energy through fusion of light nuclei. This energy comes from an overall increase in stability. Due to the strong force that holds nuclei together as the light nuclei fuse to create heavier ones. To give an idea of the relative powers of these two weapons of mass destruction, consider that the A-bomb dropped on Hiroshima had a force on the order of 10 kilotons. Explosive force equivalent to 10,000 tons of TNT, while a common H-bomb has a force on the order of 10 megatons. Or 1,000 times the explosive force of the A-bomb used at Hiroshima.
How many elements are there, and will more be discovered?
As of the writing of this book, 118 elements have been discovered. The lightest element, with only one proton and an atomic mass of 1.00794 g/mol, is hydrogen. The heaviest is ununoctium with 118 protons and an atomic mass of 294 for the only detected isotope. Considering that 5 new elements have been discovered since the year 2000. It seems very likely that more elements will be discovered. It is getting harder and harder for scientists to discover, or synthetically create, new elements, though, because the heaviest elements that have been observed to date are usually unstable and decay extremely quickly.
How are soft drinks carbonated?
Soft drinks are carbonated using pressurized CO2 gas and a siphon. That introduces the pressurized gas into the water or soda. The CO2 gas is forced into the liquid at a concentration beyond that which could exist under atmospheric conditions, and then the container is sealed, preventing it from being released. That's why if you leave a glass of soda sitting out, it will go flat, the CO2 escapes into the air.
What is a mole?
The SI unit used to describe the amounts of chemical, 6.023 x 1023.
What is an electrochemical cell?
One common example of a redox reaction in electrochemistry involves the transfer of electrons from zinc Zn, metal to copper, Cu, ions in an electrochemical cell. Zinc, Zn, gives up electrons more readily than copper, Cu. So electrons spontaneously transfer from the Zn metal to the Cu metal, depositing Zn2 plus ions into the solution and causing Cu metal to come out of the solution and onto the solid. This process releases energy, which can be used to drive external processes, such as powering a light bulb, for example.
How does NMR help chemists determine the structure of a compound?
The peaks in an NMR spectrum can be related to certain properties of a molecule's structure. The number of peaks present tells how many types of chemically distinct atoms of a given element are present.
Can more than one packing arrangement exist for a given chemical molecule?
Yes, this is referred to as polymorphism, and examples are known for most types of crystalline materials, organic and inorganic molecules, polymers, and metals. The way in which molecules pack in the solid state can actually alter some of its properties. Some pharmaceutically active molecules have more than one solid-state structure, or polymorphs. Sometimes certain polymorphs of drugs can be more useful. For example, a specific arrangement could be more soluble, making it more active in the human body. A second polymorph of aspirin, acetylsalicylic acid, was discovered in 2005, but it's only stable at -180 degrees Celsius.
What is a stable octet?
The term stable octet describes the fact that many atoms in molecules are most stable when the valence shell contains effectively 8 electrons. This counts both non-bonding electrons and electrons in chemical bonds between atoms. Molecules tend to be most stable when the valence shells of each atom in the molecule contain 8 electrons. In the Lewis structures for F2 and CH2O, see the previous question. We see that the fluorine, carbon, and oxygen atoms are each surrounded by 8 electrons. We get this total by adding both the non-bonding and bonding electrons. Since hydrogen atoms are in the first row and have just a single orbital in their valence shell, they only need 2 electrons, a single bond, to fulfill their analog of a stable octet.
What is a colloid?
Suspension of particles of one substance in another, e.g., milk.
What is quantitative analysis?
Analysis of the specific amounts of the constituent species present in a sample.
What is a geometric isomer?
A molecule with the same molecular formula but different arrangement of those atoms in space.
What is stoichiometry?
The ratio of quantities in which reactants are consumed and products are formed in a chemical reaction.
What is crude oil?
Crude oil is the oil that is found underground in natural reserves. It is formed from the natural decay of living things that were in the sea millions of years ago. Which is why it's commonly called a fossil fuel. The key ingredient that makes oil a valuable energy source is hydrocarbons. As we discussed briefly in chemical reactions, hydrocarbons release substantial amounts of energy when they undergo combustion reactions.
What is work?
A force acting over a distance, such as a person lifting a box.
Is there water on other planets?
There is, though in most cases where water exists on other planets it does not exist predominantly in the liquid form, like here on Earth. On some planets there may be trace amounts of water vapor in the atmosphere. Beds of ice on a planet's surface, or superheated, ionized water near a planet's core. There may well be other planets out there with liquid water. but humans have not found many with large amounts of liquid water.
Why did Aaron C. Chanover, Israel, Avram Hershko, Israel, and Erwin Rose, United States, win the Nobel Prize for Chemistry?
For the discovery of ubiquitin-mediated protein degradation. While the overwhelming majority of biochemical research on proteins has focused on how they are synthesized and how they function, these three researchers took a unique path and studied how cells regulate their breakdown. They discovered that proteins are broken down and rebuilt at a much faster rate than anyone probably would have expected. Proteins are labeled when it is time for them to be broken down, and then they are chopped up into small pieces so that they no longer function.
What is the hapticity of an organometallic ligand?
The hapticity of an organometallic ligand is a pretty simple concept. It just tells how many atoms from a given ligand are coordinated to the metal center. This is typically denoted in chemistry literature with the Greek letter eta.
What is kinetic energy?
Energy of an object due to its motion.
Why is there lime in my tortillas?
First, let's clarify the question. We're talking about traditional corn tortillas. And by lime we're referring to a calcium hydroxide solution, not the green fruit. Corn tortillas were historically made from what is called nixtamalized corn, which involves soaking corn in a basic solution like calcium hydroxide. The process goes back about 3,000 years to the Aztec and Mayan civilizations. Because of its ancient origin, how it was discovered isn't clear, but why it survived is now obvious. Corn lacks one of the essential vitamins required in human diets. It doesn't have niacin, also called vitamin B3. People who don't get enough niacin in their diet develop a disease known as pellagra. Just like if you lack vitamin C, you get scurvy, which has some awful symptoms. Obviously this is a problem if your civilization's staple food is corn. Somehow, the Aztec or Mayan people figured out that cooking corn with strong bases prevented people from getting pellagra. Now we know this is because niacin is not readily available in corn, but can be released by treatment with a strong base.
Why did Adolf Otto Reinhold Windaus, Germany, win the Nobel Prize for Chemistry?
for his research into the constitution of the sterols and their connection with the vitamins. Windaus was awarded the Nobel Prize for discovering that cholesterol, a sterol, was removed to cholecalciferol, vitamin D3, through a series of several steps. One of Windaus' doctoral students, Adolphe Butenandt, was himself a Nobel laureate.
What is a metalloid?
Metalloid is a term for elements that are sort of metals, and sort of not metals. Sometimes this group of elements is referred to as semi-metals. To be more precise, these elements exhibit some of the physical and chemical properties of metals. Generally, metalloids have some electrical conductivity, but not nearly as much as true metals. Because of these ambiguous definitions, even which elements are called metalloids can vary. Usually boron, silicon, germanium, arsenic, antimony, and tellurium are included as metalloids, sometimes polonium and astatine, rarely selenium.
What is electrochemistry and how was it discovered?
Modern electrochemistry studies reactions that take place at the interface of an electronic conductor and a source of charged ions, possibly a liquid. The development of electrochemistry began with studies on magnetism, electric charge, and conductivity. The earliest experiments typically focused on questions surrounding properties of materials. For example, which materials can be magnetized and which materials can be charged. As early as the 1750s, scientists had discovered that electrical signals were important to human life and were using them to treat medical issues such as muscle spasms. In the late 1700s, Charles Coulomb developed laws describing the interactions of charged bodies, which are still used widely today and taught in any introductory course on electricity and magnetism. The first electrochemical cells were developed during the 1800s. Electrochemical cells are arrangements of electrodes and sources of ions that either generate electric current from a chemical reaction, or alternatively, use electricity to drive a chemical reaction. Today these cells find applications in daily life, such as in the batteries that power your car or cell phone. Today electrochemistry still constitutes an important field of research and is one that will likely continue to lead to the development of new products and technologies.
Why does lemon juice prevent fruits from browning?
If you put lemon juice on your fruit after cutting it to prevent browning, this is an example of that last category of preservative, one that slows some enzymatic process. The vitamin C lowers the pH, because it is an acid, slowing the enzymes polyphenol oxidases and tyrosinases, that cause browning of your fruit.
What is fission?
A nuclear reaction in which a nucleus splits into smaller parts.
What is a critical point?
A critical point is a combination of temperature and pressure. Values above which a phase boundary no longer exists. There are liquid-liquid critical points above which the two liquid phases become miscible. And also liquid-gas critical points above which the boundary between the liquid and gas phases disappears and the substance becomes supercritical.
What is carbon sequestration?
Carbon sequestration and carbon capture are processes to remove carbon dioxide, CO2, from the atmosphere and store it. This is exactly what plants do when they convert CO2 into other molecules like sugars and proteins. Carbon dioxide can also react with water and limestone, CaCO3, to form calcium bicarbonate. Ca, HCO3, 2, in an inorganic example of natural carbon sequestration. Generally, though, this term is used today to refer to man-made processes for removing CO2 from the atmosphere or for capturing it before it gets released, like from power plants. A number of approaches to long-term carbon dioxide storage are being, or have been, tried, including pumping the gas deep underground into natural rock formations, scrubbing the CO2 out from flue gas by reacting it with bases, or transforming the CO2 into other useful molecules for making polymers, just to name a few.
What is potential energy?
The energy contained within an object as a result of its current state, its charge distribution, its position relative to other objects, etc.
What about the fake diamonds at jewelry stores? What are those?
Diamonds themselves cannot be made in a laboratory very well, but crystals with similar properties and appearances can be made. One popular type of simulated diamond is a cubic zirconia crystal, which is a crystal with the chemical formula ZrO2. Cubic zirconia are more dense than diamonds. Or, in other words, a cubic zirconia is heavier than a diamond of the same size. They are also a fairly hard material as minerals go, but they are not as hard as diamonds and can be scratched by diamonds. Cubic zirconia are usually colorless, which isn't the case for diamonds. Most diamonds contain some amount of non-carbon impurity that makes them appear colored. And only very pure diamonds appear colorless.
What are the goals of green chemistry?
If you have read through the 12 principles of green chemistry, you will likely have realized that the focus of green chemistry rests on minimizing the impact of the development, manufacturing, and use of chemical products on the environment. While these 12 principles may not enumerate every possible method for reducing the impact of chemicals on the environment, they provide a foundation for the outcomes that green chemistry seeks to achieve.
What is an atomic mass unit?
One atomic mass unit has a mass of 1.66 x 10 to 27 kilograms, which is about the mass of a single proton or neutron. These units are convenient, since when the mass of atoms is expressed in atomic mass units, their masses come out to values that are very close to integers. The values of mass given on the periodic table are expressed in atomic mass units.
Where do we get uranium?
Uranium is mined largely in Kazakhstan, Australia, and Canada, although the U.S., South Africa, Namibia, Niger, Brazil, and Russia are also significant producers. Uranium is mined using a leaching process that allows it to be dissolved from ore deep in the mine and then pumped to the surface, where it is extracted and concentrated for use.
What is chirality?
Chiral objects have non-superimposable mirror images.
What is natural abundance?
Relative abundance of different isotopes of an element found on Earth, i.e., not produced in a lab.
You might ask then, what is this trans fat everyone talks about in foods?
First, we should point out that most of the double bonds in unsaturated fats are in the cis conformation, where both carbon substituents are on the same side, in nature. Trans fats are fats that have had hydrogen artificially added, which can result in unsaturated fats with a trans conformation about the double bond. There is evidence that these trans fats can be more harmful to your health than other fats.
What is an electrolyte?
An electrolyte is a substance that contains ions, charged particles, and is capable of conducting electricity. Most often this is a solution containing dissolved ions. like an aqueous solution of sodium chloride, which contains Na and N-clions. The presence of ions in the solution is what makes it capable of conducting electricity. It's for this reason that it can be dangerous to get the electrical outlet wet when drying your hair in the bathroom. Pure water itself doesn't conduct electricity, but in practice, there are almost always some ions present, making tap water an electrolyte. Another place electrolytes are important is in living things. Fluids in the human body, and in other organisms, contain free ions and are thus electrolytes. Gradients in ion concentrations in cellular fluids are often important for regulating cellular processes and bodily functions such as muscle and nerve activity.
What is a beta particle?
Beta particles are another type of particle that can be emitted during a nuclear decay process. A beta particle can be either an electron or a positron, which is the antiparticle of an electron. If it is an electron being emitted, one of the neutrons in the nucleus must become a proton to conserve charge in the process. Beta decay increases the number of protons in the nucleus by 1 and leaves the atomic mass essentially unchanged.
What is a barometer?
An instrument used to measure pressure.
What are stereoisomers?
Stereoisomers have the same number of atoms connected in the same order, but differ in their arrangement in space. There are two major types of stereoisomers, enantiomers and diastereomers.
What is alpha radiation?
Alpha radiation involves the fragmentation of the nucleus into two particles, one consisting of two protons and two neutrons, an alpha particle, or in other words, a helium nucleus, and the other consisting of the remaining protons, neutrons, and electrons initially present in the parent nucleus. Alpha decay decreases the number of protons in the nucleus by 2 and decreases the atomic mass of the nucleus by 4 amu.
What is a monodentate ligand?
A monodentate ligand is a ligand that coordinates to a metal center via a single atom on the ligand.
What is meant by dynamic equilibrium?
Equilibrium conditions in a reversible chemical reaction are described as a dynamic equilibrium. This means that even at equilibrium the reaction has not stopped, and the forward and reverse reactions are still taking place. The bulk concentrations of reactants and products don't change. But this is just because the forward and reverse reactions are happening at equal rates. The reaction never stops, it just reaches equilibrium.
What is a rare earth element?
Term for the lanthanides and actinides, including scandium and yttrium.
What is dextrorotatory?
Having the property of rotating plane polarized light clockwise.
What is plasma?
Plasma, the fourth state of matter, is a gas where some amount of the particles have been ionized. As little as 1% ionization leads to very different properties for plasmas than gases, including increased conductivity, like lightning, and magnetization.
What is Coulomb's law?
Coulomb's law tells us the force experienced by a pair of separated charges. It's a fundamental equation in the study of electrostatics, which is a broad area of physics concerned with the interactions between stationary charges. The key features of Coulomb's law are that it predicts an attractive force between particles of opposite charge and that this force decreases with the square of the distance between the particles. For chemistry, it's relevant to point out that the force between charges falls off rather slowly with the distance between them, so where charges are present in relatively dense materials, like liquids and solids, they have a significant effect on their environment.
What makes string cheese stringy?
In the United States, string cheese is usually mozzarella, sometimes with some cheddar thrown in. The production process takes melted cheese and stretches and folds it in a single direction. This stretching aligns the proteins in the cheese, making it possible to peel off long strings of it.